as far as like, if you're going to find values of t, okay, I'm just going to pick some randos. I did -1, 0, 1, 2 is what I did on mine. So you can see what direction the curve is going. I didn't pick numbers too big because my graph's not too big. So again, if you need to find an x coordinate, you just plug -1 into the equation. So like you plug it in for x. So it's like you're doing -1 squared over 2 plus -1, right? So it's -1/2. Figured it out. And then to get y, you do the same thing. But you just do -1 cubed minus 5 times -1. So is that 4? You don't need to show it plugging in. Like, you guys can do that in your head. But this first point here, so -1/2, comma 4, looks right about here. Oh, wait. Hold on. 1, 2, 3. Yeah, that's right there. Okay, so that's like where you're starting. And then if you keep filling in your chart, you can get like what the arrow or what direction the curve is going. So if you plug 0 in, you get 0, 0. Right? So then that means my curve's going this way. And then plug it in. And then you could see 1.5, -4, going this direction. Right, so you can see how the graph is going. Oops. So then you can assume the rest of the curve is going that way. So it's starting down here and then looping up. Okay. All right, as far as domain goes, essentially what you do is you combine the two of like what the domain would be for t. So what you're going to do is you take this guy. Guys, please. So for this one, like t has to be bigger than 1 because you can't take natural log of 1, right? Or, I don't know, I'll show this, I guess. So it'd be like t minus 1 has to be bigger than 0, you know. So t has to be bigger than 1, right? For natural log. So that's like old school stuff. And then this one, you can't divide by 0. Right? So t has to be greater than 0. So essentially, for the domain, okay, I feel like this should be... No. So then, why do I have 1 to infinity? Yeah, because so then like t has to be greater than 0 and t has to be greater than 1. So to combine them together, like a half would work for the blue one, but not for the pink. So to combine them all, your domain would be from 1 to infinity. If you take a math class after this, they use this notation. Oh boy, I'm out of practice. This set notation. Do you remember this in pre-calc? So they say this is the variable. This is just for fun facts so you remember it. You take anything after. And then you go the domain. So it's just a different way to write it, but it's a thing. Because once you get into vectors, they usually use the set notation. Yeah. Yeah. Okay. If you have to do a limit, you just take the limit of each. So it's not too bad. So to do this one, you just do that. Sorry, I did that really fast. I just plugged 0 in. So e to the 0 is 1, right? And then this one, okay, for this one, this limit you can solve a couple different ways. I'll show you both. Because like sine of 0 is 0. And then you could do L'Hopital. That's one. Or, I don't know, this is a little bit of a throwback. If you wrote it like this. Remember that? Because this guy's like a famous one. This one's 1. So it'd be 1 times a half. Okay. Or you could do L'Hopital, which is might have been your go-to, but I just want to remind you about that one. You could do L'Hopital. So you just take the derivative, and then you get a half. So it's really whatever you want. So the notation for it, you do this like bracket thing, like arrowy brackets, and it's literally like the order pair. It's not too crazy. If you do the equation expression thing, it would be 1i plus 1/2 j. So that's kind of fun. Okay. I mean, a lot of the vector stuff, it's like the same as like your normal derivatives. Like if you have to do continuous, like everything's the same as what you did way back in the day. It's just now you're dealing with t, and it's essentially like you're looking at both. So instead of just looking at one like equation or an expression, you're looking at both of them. So like determine which of the following vector valued functions are continuous for all real values of t. So it's like you're looking for asymptotes, corners, like that kind of stuff. Well, not corners, but like asymptotes, removables, all of that stuff. So like t squared's fine, that's just like a parabola, but like tangents has asymptotes on it, you know? So like this one's not continuous because of the tangent. So if it doesn't work for one of them, it's not continuous. So this one's not continuous because at t equals like negative pi over 2, yada, yada. It doesn't work. Okay. And then this second one, we've got a polynomial. Parabola is normal. E to the t, that's just an exponential function. So because both of them are like continuous on their own, you can say the whole thing's continuous. Right? And then look at the next one, e square root. You can't square root a negative. So it's, nothing's like crazy new. It's just now you're just doing double. That's the only difference. Because like if t is negative, you can't square root it. It's not continuous. And then here you go, fractions are always red flags. Like when t equals 2, that's not continuous. And then this one is just constants. Like, just think of like, this is x equals 3, y equals 2. Those are just horizontals and vertical lines. So this is continuous. So it's just double, 2 for 1. Okay. Derivatives, same thing. You're just doing 2 in 1 problem. So if you're doing the first derivative, because you're taking it with respect to time, this is the first derivative is going to be fine. Second derivative is also going to be like normal, quote unquote, because you're taking a derivative with respect to time. This like fancy formula thing, you're taking the derivative with respect to x, so you have to do all this like fancy stuff. Okay, but like for this one, you already have your equations in terms of t. You're finding derivative in terms of t, normal. Second derivative in terms of t, normal. You're just doing it twice. So like to find r prime of t, you do a little bracket thing, and then you're just going to do the derivative of this. So, you know, some cute chain rule on there. So it's going to be 5. Woo. It's going to be 5, and then I'm going to put the chain out front. So it'd be e to the t squared plus t is like derivative of e, but then I have to do chain rule, so that'd be 2t plus 1. So that'd be the first one, and then you do the second one. So natural log is 1 over the crazy, but then you got to do chain rule. So 2t plus 1. And then that'd be done. So that's like normal. Second derivative is just kind of horrible because usually, you know, like here now we have product rule and a quotient, so you kind of cry a little, but it should be fine. Hopefully, maybe. So yeah, like this first one, just a little review, I guess, with doing product rule. You take the derivative of the first times the second, you know, plus the derivative of the second times the first. So it's like nice and long. Yay. So derivative of the first would be 10 times the second plus the derivative of the second, which is basically the same thing, right? Because derivative of the second we kind of already did, times the first. So essentially, well, yeah, that's fine. I'll just do it. It'd be 2t plus 1 e to the t squared plus t, and then times the first, which then gives you a, gives you the 5, right? And then this ends up being, you now have 2 of them. And then comma, and then quotient rule, which is my favorite. Just kidding, I hate quotient rule. So derivative of the numerator times the denominator minus the derivative of the denominator times the numerator all over denominator squared. And then you just clean it up a little. So. Okay, I'm going to factor out the e stuff in a 5. So if I factor out an e, I'm just left with what? 2 plus this thing squared, right? Yeah. Let's see. And then, let's see, what does this whole numerator turn into? We got 2t squared minus a 4t, so it's negative 2t squared. And then we got 2t, and then a 4, so negative 2t. And then, what is that, 1 minus 1, I think, right? Yep. So, algebra. Ah! There you go. questions on that? Just do them separate. Normal. Just 2 for 1. Isn't that exciting? Okay, last page. I know, sorry. Guess what you do with integration? Same thing as 2 for 1. So it's 2 for 1. So, why does it keep doing that? So if you need to integrate this, gosh, my voice is horrible. You're just essentially doing 2 for 1. Yay. It's like you're integrating that one, and then you're integrating 1 over t. So 2 for 1. The part that might be weird is you got 2 c's now. So they just do subscripts for them. So they'll do like, what is this, 1/3, oops, let me do color here. This would be 1/3 t cubed, you know, but then it'll be plus c. There's going to be 2 of them, so just put like a subscript 1 for the first one. And then you do the same thing with the other one. So it'd be natural log absolute value t plus c sub 2. So that's the new thing, is there's 2 c's, so just be organized. If you're integrating with values, it's the same thing, 2 for 1. You're just integrating them separate. So this one, it's essentially, you're going to integrate from 0 to 1 of e to the negative 2t dt. And then integrate from 0 to 1 of 1 over t plus 3 dt. I mean, you could do a u sub on the pink one, but since it's just like negative 2t, like it's pretty basic, you're going to have to multiply by negative half. Remember? So like, you have to like undo the multiplying by 2 when you do a derivative. So to integrate that, oh my gosh, it's going to be negative a half e to the negative 2t. You know you're doing these right, because if you took the derivative of it, you would get that back. You know, and we're not going to have the plus c on this one, because you're just doing normal integration with values. So you're going to like plug in the 1, plug in the 0, and all that stuff. And then this one, the t plus 3, you could do a u sub also, but because it's not like super complicated, it's really just going to be t plus 3. You don't even have to do any chain. Like say there was a 4 in front of the t, then you would multiply by 1/4, right, to combat the chain rule. But since it's just a plus 3, you're not going to have to deal with it, and that's from 0 to 1. And then you just plug in the stuff. So, yeah, I don't know. It's like you've done it before, but now you just do double. That's fine, right? And then things to keep in mind, like if these are usually going to be multiple choice, if we're being honest here. They're going to do the log rules for like the second part. So for this first one, that one's pretty normal, but then what I'm saying is they're probably going to write this as natural log of 4/3. So keep in mind that like they're usually doing that for the multiple choice. So is there any questions? Okay, this is just notation. Essentially what you're going to do is it's like a fancy way to find C. So this stuff in front of I is your X stuff, and this stuff in front of J is your Y stuff, okay? So we'll deal with the R of 0 thing in a second, but essentially this is how you break it up. You're going to integrate sine 2t dt times I, and then you're going to integrate. It's like you're distributing the integral, kind of, in a way. So the i's and j's kind of just like tag along as you go. So like as far as the notation's concerned, it's kind of like you're distributing the integral in a way, and then the i's and j's kind of go with it. And now you're just integrating. And this one's going to have c because there's no bounds on it. So it's going to be, okay, so 2t then, that means I'm going to have half to undo it. But then antiderivative sign is negative cosine. So it'd be negative a half cosine 2t plus c sub 1. And again, the reason we're doing that because we don't have bounds, right? You guys know that integral? 1 over inverse tangent, yeah. Inverse tangent, yep. Good job. And then plus c sub 2. Okay, so now, once you have it integrated, you're going to like solve for c. So you know how they give you like the initial condition or whatever? These are like the initial conditions. So like this guy here is saying like x of 0 is a half. So it's like, that's coming from this thing. Excuse me. And then y of 0 is the number in front of j. 1. So you're going to solve like these cute little algebras to get your c's. So you're going to do the 0 and the half for the x stuff, and then the 0 and the 1 for the y stuff, and then you'll be done. So for the x, you're going to go negative a half cosine 2 times 0 plus c sub 1 equals a half, and then you're going to solve that. And then you're going to do the same thing, inverse tangent of t plus c sub 2 equals, oops, not t, I have to plug 0 in, silly, equals 1. So you're going to solve like each of those little guys to get your 2 c's, and then that's it. So what is this one we get? That's 1, right? Cosine of 0 is 1, and then we add it over. So c sub 1 would be 1, because you'd add 1/2 over. And then this one's tangent of 0 is 0, so c sub 2 is also 1. Well, that's cute. Okay. So then you just re-plug it in to your stuff. So you're going to have all this junk in front of I, and then all this junk in front of j. So you put all the x stuff in front of I and all the y stuff in front of j. And then this one would be, and there you go. Weren't you guys like, man, I wish I could do 2 integrals in a problem, you know? Definitely so fun. Okay. This one is like the same thing, only a little more hardcore because you're going to have to do it twice. So you're going to go, you have to find r of t, and you're given the second derivative, and you're given an initial condition and another initial condition. So, yay. So this is what I'm saying. So r, actually, maybe I'll just go straight to, so r prime of t is essentially, you're going to, you know, all your stuff in front of I is all your x stuff. It's essentially, you're going to integrate negative 4 cosine t dt. right? Because you're going second derivative, first derivative. And then you could put plus, or I kind of like to write plus a negative, but that's me. I like to write plus, and then I write it as -6. Oops, I have to put the integral. Times j. So it's like, so my first derivative is I'm going to integrate that, get my, so this is still r prime. Now I'm just integrating it. So what would that be? That'd be still negative, right? Yeah, -4 sine t plus c sub 1. And then this one would just be -6t. That one's not bad. Oops. And plus c sub 2. It's j. Okay, so now you're going to find your c's. So just like the other one. You might freak out though because it's not like an adding thing, you know, like the other one. It's just like this 3j. So you're like, what the heck? So like for this one, so maybe I'll write it over here. So r prime of 0, think of it as 0i plus 3j. You know what I mean? Because then it's basically saying when you plug 0 in for the, like the t for the x, you're going to get a 0 for the x. So if there's not an I around, it just means that it equals 0. Okay, so you're going to solve your cute little guys for your c's. So you're going to go -4 sine t plus c sub 1 equals, oops, I'm going to plug 0 in. Because again, there was, right? There's no I. And then you're going to do the same thing, -6t plus c sub 2. Oops, I keep putting t in there. And then that one, I'm going to plug 0 in because that's the t, but it's going to equal 3. And then you solve your c's. So this one is just 3. This one is 0. So that was anticlimactic. Okay, and then now you're going to do it again. So your r prime finale, anyway, I guess, r prime is just -4 sine t, and then the c was just 0, so that's lame. And then your other guy was -6t, but then your c was 3. That's your j. And then now you do it again, but now it's for regular r. So then for your c's, you call them sub 3 and sub 4, so you can keep your life organized. So now we're going to do it again. Yay. Loving life. Right, so we're doing the exact same thing, but now we got c sub 3, c sub 4. Oh, man. Okay, we can do this. It's going to be +4 cosine t plus c sub 3. Oh my gosh, I'm going to run out of room. Let's put this here. And then what is this one? -3t squared plus 3t plus c sub 4. Okay. And then you use the next one again. So it's like, now we're using this initial condition, and now you have a 0 for the y part, essentially. So you get, so for r equaling 0, That's the same thing as r of 0 equals, x of 0 equals 2. And then this one would be y of 0 equals, oh my gosh, what's wrong with me? Y of 0 equals 0, because there's no j. And then you're going to use it to solve the c's. The second round of c's. Okay. All right, so okay, so what is that? -4 or 4 cosine t plus, what would c sub 2 be? For -2, right? Oh, I should write -2. I plus, and then you would do, this would be -3t squared plus 3t. And this equals 0, so that just goes to 0 anyway, so that's fun. Okay. So here, this c sub 3 was -2, c sub 4. So just double time. Hey?
You just did all of ABs in like 1 minute. Twice each time you finish.
Yeah.
In one
I
day.
know, don't you feel smart?
Do you have to like show solving for C? This is great. Can you just like put it in?
No, that's like kind of why I did that in that last one.
No, but you like.
I did put it
Do you
there,
have to show
but
the
you don't need to
C's?
show
Like,
it though. Because it's usually multiple choice anyway.
on my homework, can I do like that? Is it fun?
For what? Oh, okay, perfect, because I was running on radius.
Oh. Yeah, it really is like A, B in one lesson. Because you did like U sub, like